In this video, I'm going to briefly look at some basics about predicting where the Big Island volcanic eruptive plume may go in the event of an explosive eruption or just under normal conditions. In this image, you can see the plume as this sort of hazy area underneath the white clouds stretching out from the Big Island. Before I say anything, your first point of information should be the National Weather Service and the USGS Hawaii Volcano Observatory web pages that have amazing amounts of information, pictures and videos. It's fantastic. And even right now, the National Weather Service has a special weather statement that details information about the ash and the plume and the areas of risk from this plume. What I'm going to talk about in this video is more to go a bit deeper and to develop your own understanding as to why this plume might go in certain directions and that sort of thing. Let's start with this rather nice view from the Himawari 8 satellite, and Hawaii is off on the limb here. Probably not the best satellite image to really be using right now, but it looks pretty nice. And if you look very carefully, you can see hazy areas where the ocean is not quite so blue. And these are actually bits of the volcanic fog, or VOG, basically haze, that's come from the volcano, and it's mixed up in various systems and whatnot. You can see it closer to the island over here. So the first thing I want to just show is a few pictures and videos that show the effects of the wind. So I'll start with this example. This one was on 24th of May, and you can see the explosive ash coming out of the crater. But the thing to note is how the reason why they can film this is because the plume is going the other direction. You can see the plume trailing off into the distance. Now, the ash falling out of, in this case, will be down on the other side, heading off in that direction. Here's another plume example. This time it's of the lava entering the ocean, and you can see that the plume is spreading roughly down parallel to the coastline. Now, this is actually in a southwesterly direction, and the reason why it's moving in this direction is because it's being pushed by the ever persistent Hawaiian trade winds, and that is a very persistent flow. And if you look at the map on the right, or the Google Earth image, it's because the winds are generally moving down the coast like this and pushing the plume. The plume will tend to then wrap around and go around the southern side of Mauna Loa. Here's another example of wind shear affecting a volcanic plume. This one's in the recent eruption in Japan, and there are a few things you can note from just this simple image. The first is that the plume moves up like this and then moves off towards the left, so it's getting pushed by winds that suddenly get stronger around this level. The other thing is that it's flattening out, so there's probably some kind of cap limiting the vertical extent of growth of this plume. So we've got this wind directional change and the plume off to the left. The other thing, if you look carefully, you might actually see that this lower level plume is tilting slightly away from the camera. This is an indication that the low level winds are pushing in this direction, and this is further emphasized by the ash fallout, which can be seen to be moving into that air and flowing off in this direction. So there are a lot of things that are revealed in just this image about what the winds are doing to this volcanic plume, and even a little bit about the temperature structure in the atmosphere. The reason why you should be concerned about volcanic ash and gases is described here on the USGS page. It's basically because there are tiny jagged pieces of rock and glass, and they can cause various health problems, as well as dusting your garden with some nasty crap. So here we are on the 28th of May, a few days ago, and you can see the Big Island is up here, and the plume of VOG, volcanic fog, yeah, that's what it is, is spreading off towards the west, slightly south-southwest. Now, as we move forward in time, we'll actually see this plume getting sucked up into this storm system up here. Look at that. It's pretty impressive. And actually, this system isn't a surface system, so that means that it's an upper and mid-level low pressure system. So the winds are rotating, as you can kind of see here, but they're above the surface. So at the surface, most of the winds are generally still easterly trade winds. So this is an interesting point. The reason why it's an important point is because it demonstrates how you need to look at winds throughout the atmosphere, and particularly above the surface. Because if you just look at the winds at the surface, then this plume will just head off towards the west indefinitely. But in this case, because the plume itself began at around 1,500 meters or something like that, it's getting pushed into flow that's actually above the surface and is behaving very differently from the surface. In this case, getting wrapped up rather beautifully into this mid to upper level low pressure system. So if we go back to May 29th and look at the winds, here are the surface winds, and you can see that they're generally moving towards the west. This is the trade winds are easterly. So in this situation, you would expect the volcanic plume to just head off quite happily off towards the west, but we know that that's not what happened. We know that it got wrapped up because we just saw the image. So we can actually look at the winds a little bit higher, and this is more like around 4,000 meters, 600 millibars. And at this case, now you begin to see that mid to upper level low pressure system, and that is then sucking up the plume, which originated above the surface anyway, but also penetrated higher. And it's getting wrapped into that system, as we saw. Now, imagine a plume that was even deeper, one that got up to 250 millibars. Well, up there the winds are howling. In that case, the plume would have started to shoot off in the opposite direction, and yes, basically off towards the east, which would have been kind of nuts. So I think the point that I'm trying to make here is to explain that the winds in the troposphere are moving in different directions. In fact, if you look at this satellite image, you can see these high clouds, and they're moving in this direction. But the low clouds, or the lower trade wind clouds, they're moving in the opposite direction. This is over a space of 10 to 15 kilometers in altitude difference across. And here we've got the Big Island. So a volcanic plume that penetrates into this atmosphere will move in different directions depending on how deep the volcanic plume actually goes. As we saw with that upper level low pressure system, if it gets into the middle atmosphere, it'll move off in the middle atmospheric flow. So we really need to get a good idea as to what the winds are doing at different layers in the atmosphere if you want to predict where this plume will go and where the localized ash will fall. If you want to get a view of what the winds are actually doing throughout the troposphere, to get a better idea as to what this plume might actually be doing, you can go to this site, which is the Wyoming sounding site, and you'll get the latest observations coming from a weather balloon. And on the right of this graph, you'll see the winds. And these winds indicate that at low levels here, they're coming from the east, as is typical for Hawaii in the trade winds, and then they switch to being wests and strong west winds up high, and the heights are indicated on the left. So you can see the transition layer, which is around here, is roughly at 4,000 meters, which is actually roughly the height of Mauna Loa and Mauna Kea on the Big Island. So I'm going to draw that in. There we go. So the thing is here that if you get a volcanic plume or explosive eruption that blows up through all these layers and gets up into higher layers, then it's going to start moving off towards the east in the west winds. The west winds will push the plume off towards the east if it's very, very deep and explosive. This doesn't often happen. Typically it's, the Vog plume is going off and it stays in this layer and it heads off in the other direction. So you get the issue. And the eagle-eyed of you will have noticed that there is, of course, the extremely strong trade wind inversion here, and that would inhibit the growth of a typical convective plume, but a volcanic plume, a strong volcanic plume, would likely break right through this layer, I would imagine. And just to confirm on the heights are actually these numbers here, not these ones. These are pressure. The final thing I'll say about this diagram is that the boundary between the troposphere and the stratosphere is actually up here. It's when you start to see the temperature, which is this right curve, start to bend to the right, indicating that it's stabilizing. It's no longer decreasing much with height and may even begin to increase with height. That height is around 15 kilometers above the surface. In the event of an extremely strong eruptive plume that was erupted from Kilauea, I would not be surprised if it got up to these heights throughout this whole layer. No idea whether we'll actually see something like that, but in that case you're talking about a really thick plume heading off towards the east of Hawaii. So this is going to go in the opposite direction. A big plume is going to go in the opposite direction to where it typically would go. That's the point here. Well, I will say one very final thing about this, which is that they are saying that the eruptive plume could get, in the case of an explosive eruption, up to 20,000 feet. 20,000 feet is actually only 6,000 meters, right? So that's actually only here. Now, that means that the plume, in that case, would go and then it would bend around in these winds. But here's the issue here is that if there's a hot convective plume and it gets to this level, I don't really see any reason for it to stop rising at that level. It's already past the inversion, and I would think that it would continue to rise convectively and go much higher than 20,000 feet. So with all that being said, let's assume that the plume gets to, if there's an explosive eruption, let's say it gets to 20,000 feet. What are your best resources for seeing where this plume is going to go? Well, I would recommend the Department of Meteorology and looking at the winds. For starters, they give you 4 levels, although the bottom 2 are basically the same thing. You've got the surface, 600 and 250 millibars. Looking back at our sounding, you'll see these levels, 600, 1000, and the surface is basically there. And then 250 millibars. These are the levels that are being plotted from the model. This one is about 4,000 meters, so roughly the size of the volcanoes on the biggest volcanoes, Mauna Loa and Mauna Kea, on the Big Island. 250 will give an indication of the upper level flow, and this is below the boundary between the troposphere and the stratosphere. So remember, if it's a very, very deep flow, deep convective plume, a deep eruptive plume, it will enter into this layer. But let's concentrate on the 600 hectopascal layer, 4,000 meters, 4 kilometers above the surface, and have a look at what the winds are going to be like in the next few days in that layer, and as a general indication is what you should look at in the future. So let's take a look at these 600 hectopascal winds, roughly the height of Mauna Loa and Mauna Kea. As you can see at the beginning, they're actually coming out from the north and then bending round. So if the volcanic plume enters into this layer, as it's probably doing at the moment, you should see it blowing off in this direction, and even coming back around in these winds over here. But let's get rid of my little arrows here and move forward. As we move forward in time, by the 2nd of June, we've got winds going in the other direction, bringing things up in this direction. In this case, you would expect the haze and smoke, the volcanic haze, to move up towards the north. And I'm guessing that's what is expected to happen at this point. So perhaps reaching the minor islands. In the event of an explosive eruption, this would be a concern because it would hold the explosive column quite local and even maybe push it slightly to the north. So in conclusion, this is my rough Friday night type video, and let me know if you find any problems here, any suggestions. Really, I would much appreciate any suggestions, websites you know of, and I will correct, update, and probably re-upload if there are significant corrections to be done. And let me know if there are any questions on this video. I will be happy to answer them. See you later.